All right, so this video is going to go over this APCSP string practice quiz number 2. So it says Everett is developing a photo editing app. Here is a part of his program that sets up some variables: filter, width, border, file name. How many string variables are there? Well, which ones have quotes around them? So 1, 2, 3. So your answer is 3. 2. Google Map lets users search for anything in the world. The code to display the map and search results relies on many variables. Which of these variables are storing a string data type? Again, which ones are in quotes? So A, D, E, F. This is an int, it's not a string. This is a double, not a string. And this is also a double and not a string. Okay. 3, the following variables are from an online music app. Identify which variables store numbers and which store strings. So string, number, string, number. Okay. Those first three are really easy. Okay. Khadija is writing a piece of code that will ask the user for one letter at a time and concatenate all the letters together to form a word. Assume that the variable x represents the letter that the user has input and the variable y represents the word the user is forming. So y is what's forming, so that's going to be what it's set to. Okay, so you can automatically cross off D because that's going to, X isn't the word you're forming, Y is. Which the following code segments would successfully concatenate the next letter. So with A, you're just taking whatever letter and putting it on there each time, and Y never has a previous value. So let's see here. 0 for one letter at a time. So let's say, we're adding the letters hello, okay, and we're doing it one at a time. So X represents the letter that the user has input. So this would be the first letter, then the second, then the third. Wow. Maybe I should just, I needed to choose this. Okay, so again, let's say you're adding these one at a time. So you've got hello that's coming on first, second, then third, then fourth, and the fifth letter. So Y is going to store these. So if A did this, Y would be set to H the first time. Okay, and then look at it. Y would be set to E then, and then L. Okay, so it never builds itself, so that's out. So what would happen here is that you'd have X, which would be H, and that would be initially blank, right? And so Y would be, so this is looking at this one. So Y would be set to H, right? And then you'd have the next letter, E, which would be put in. So E would be put in, and then Y would be H, right? Oh, this is all jacked up. You'd have, wait. You'd have, well, okay, so first of all, this doesn't work at all because you can't have an equation where you have, yeah, this looks weird. You'd have blank is equal to, so this is basically an equal statement. You're assigning something. I don't know. That's just funky to me because you'd have like a blank plus the first letter H, and that would be equal to a blank. I don't know. That's not how you do it. B is clearly the answer, and let's just look at Y. Okay, so you're basically building yourself. You take what's in Y, which is blank at first, right? And then you'd add in H, right? And then you assign that. So this Y right here would become H. And then you would take the next letter, which Y would be H, plus E, and you would assign that to Y, so that'd be H, E, and then you'd have, H, E plus L, and that would be set to H, E, L. Okay, and so then it would just go down all the way until it's H, E, L, L, O. Okay, so your answer is B on there. 5, Kanto is working on a program for generating baby name ideas. Her program uses the following procedure for string concatenation. So let's see here. In this case, the way that the concatenation works is you have a string 1, it joins 2 strings to each other, returning the combined. So it takes whatever string 1 is and string 2 and combines them to form a string. These variables are at the start of the program. Which line would store Kai? So you want this one, and then Lin, that one, to form Kai, Lin. So string, I don't know, so it'd be what? Concat first 2 and mid 2, right? Because first and second one, and it concats them together. Choose one answer. Oh, A, you're right. Did I do that right? All right, I did not do that right because look at here. There's a space. This would be, there's supposed to be a space there. This would be what would happen with no space. So this one's probably better because what you're doing, D's, so no. D's should be your answer. I didn't think about that right there, but what this should do is it concatenates a blank, so you'd have blank, so you'd have your blank space. I try to do an underscore for blank spaces. So you have a blank space and then what, Lin, for your first one, and then you'd concatenate the first name, so you'd have so the second, or sorry, first 2, you'd have Kai right there. So then you'd have a Kai space Lin. So A looks like it right off the bat, but I forgot. I just did this without even looking at it. So B doesn't work because you have 1, 2, 3 parameters. This only has 2 parameters up here. 2, so this has 3 parameters. That would be an error. This has only 1 parameter, so you'd have an error. And this one puts a period in. There's nowhere there's a period. So, and this has 3 parameters. Well, wait a second. 1, 2, yeah, that's 3 parameters. So you'd have an error there. Okay, so that would be no good. No good and no good. A kind of works. Like that's the one where if they do that in AP, they're just trying to trick you, which to me kind of sucks because it's not necessarily. I clearly knew what I was doing. I just didn't account for the space in there, where D is more correct and, anyway, you can get ahead of yourself on these tests and pick the wrong one, so just make sure you catch yourself and go through each answer. Again, it's about quality, not quantity. So 6. Ling is writing code for a a browser extension that transforms internet commands to sound less emotional. The code relies on multiple string operations, so we've got something that lowers lower cases, and we remove a string at the target, removes all the currents of the target from the string and returns a new string. Their code includes these variables, so we got comment A, B, and C. Isn't it obvious? You're so silly, I don't believe you. Which of the following expressions results in the string you're so silly? So basically this one, but it's lowercase, and the exclamation points are removed. Okay, so removes all occurrences of target. So you actually don't have to do all 3. You just do 1, right? And then it will remove all of them. There are 2 answers. So let's look at this. So comment B and then plus that. So it would remove all occurrences of you're so silly and the exclamation point, and then it lowers it. So I don't know how you lower an exclamation point, but this one would return that. So A definitely doesn't work. B, we lower that. I don't know. Again, I don't know how you lower an exclamation point. And then you remove the exclamation points at. So I guess maybe that kind of makes some sense. You would remove the target, the exclamation point, but this would never get lowered, okay? So that doesn't work. And you can't really lowercase an exclamation point. So anyway, this one right here would lowercase your comment, comma, and then remove the target, so that works. So again, you're doing the inside first, parentheses, you're lowering it. This lowers it, and this lowercases everything, and then it adds a comment at the end, and then you'd have an error because this has 2 parameters, and this is only 1 parameter. So D doesn't work, and then we remove all the exclamation points, and then so that would give you basically this without the exclamation points, and then it would lowercase it. So E, C, and E are your answers on that one. Seven. Consider the adjacent code segment. What is the output of the program? All right, so you got a string, you got a start position, and then the end position -1. It returns a string of S1 with the start position as the starting position and the end position -1 being the ending index -1. S1 index starts. Okay, so we have aardvark. I'm going to write this out over here so it's larger. R. One, two, three, 4, 5, 6, 7, 8. So we've got our aardvark that gets passed in. At position 4, we have D, and then remember this isn't going 5 places. It's the index position 5 minus 1, which gives us 4. So the starting position and the ending position being the index -1. So it's just there's a start, there's the end, that's the letter. So your answer for 7 is C. 8. Let's say for 8. Consider the adjacent incomplete procedure reverse. Procedure reverse returns string 2 at the reverse of this string 1 parameter. For instance, if we have the word, so let's write out this tornado. Tornado. Let's see here. Alright. So we're trying to get this into reverse so that it's so that would come up in reverse and it'd be O D A N R O T. I can put that there because they have the same number. They have the same index numbers. It's just that this is backwards. Procedure reverse. We pass in the tornado string. String 2 is blank, and then n would be what? 8. So this would be 8. We repeat until n is 0. So we take whatever the missing code is, and we gotta go through it 8 times to get through this whole thing. So again, this is kind of like question. We're rebuilding a new string 2. This is kind of like question 4 that I went through with you, where okay, so first time through, n is 8, right? So if you did this at position 8, you would have O right here, and you would store that in here. But then when you do 8 minus 1, you'd get 7, okay? So for this one, you get 7, right? And you go through, and then what's at position 7? You have O, and now string 2 just is O. It's not... sorry, D. At position 7 it's D. So you would not have your O right here and your D. You would just each time you would just say string 2 is D, and then string 1 would be A, and string 4 would be N. It wouldn't keep a running tally of what your string 2 is. It would just be this new string 1 at whatever position is each time. So you have to be able to store string 2 so A doesn't work. And then C wouldn't work either. If you're rebuilding it and you need to keep the original, you can't do that on those. So this comes down to B and D. Well, again, we're not looking at what position. I mean, your answer here is clearly B, because look at this. You got your original string 2, and then you're adding. So first time through here, you got blank. And then n is 8, so you got O plus O, okay? And now, and it's probably better if I did it like this. So now your string 2 is now O, right? And then you'd come through here, and now your O gets right there. And then you'd add in, so you'd subtract 1 from 8 and get 7. Well, what's at position 7? You get your D. So now you've got O and then D. And then you've got your string 2OD plus, we subtracted 1 here, so what's at position 6? Dude, no wonder I screwed this up. 1, 2, 3, 4, 5. This should be 7. So 5, 6, 7. So then you'd have, anyway, so just shift everything down 1, so instead of starting at 8, we just start at 7. So anyway, this would be your A. So then you'd have ODA, right? And then you'd come down here and you'd have ODA plus, and then, ODA, and then you'd have N. So then you have ODAN, and then so on to go backwards. So your answer is B. D is you're assigning an index position you're not assigning the entire thing. You're assigning just an index position right there, and then, you know, so these get kind of screwed up. So anyway, your answer is B on 8. 9. Okay, metadata. So if you were to recall, metadata is kind of like, so let's see here. Let's go to my desktop. If I right click and view, like a list. No, I want to do view. So here's kind of like my content, okay? This is a lot of this is metadata. So you've got your here's examples of metadata. You got the name of the file, you got the date it was modified, file size, so that's data, that's data, that's metadata. So metadata is just things about the file or the document. It has no, like, I named it that. Do I know, you know, and this is interesting, this is metadata too. It's authored by the administrator or authored by, I authored it. Is there any information about is there any information about what's actually stored inside this file? No, metadata is just information about the file itself. So when a cellular telephone sends a text message, the cell carrier encodes the text message and transmits the message to receive the receiving cellular telephone. The encoded text message is the data of the transmission. Encoded text message, the data of the transmission. In addition to the transmitting the data, the cell carrier company also stores metadata. The metadata of the text message includes the time, the phone number, and the phone number of the receiver. For which of the following goals would it be more useful to computationally analyze the metadata instead of the data? Estimate the number of text that will be sent next month. So that's basically metadata. You can look at the number of texts sent. 2, determine the most frequently used emoji in the text. Nope. Again, this is information inside the text. Okay, I just showed you that. Who knows? Do I have an emoji saved in here in this file up here, chapter 2.1 worksheets? I could have one, but I don't know that based off of the metadata. The metadata for this file says the date. It was 12/5/2020 at 8:54 a.m. and the size is 21.4 kilobytes. And the author was Michael S. Seeley. Don't know anything what's in here though. Okay. Determine if 2 phones have been in contact in the last week. So that would also be kind of metadata. You could look and see who contacted who, kind of like you could see who the author of that file was. But it doesn't say anything about the conversation that the 2 people had. That would not be metadata. So 1 and 3 are your answers. So your answer is C. 10. When a person wants to refer to a specific color, she may describe it by its red, green, and blue RGB value or by its hex code. The RGB values are decimal numbers separated by commas, and the hex code is a 2-digit hexadecimal equivalent of each of the RGB, red, green, blue values. For example, RGB value for the color army green is that, and its corresponding hex code is that. Note that, okay. If RGB value color is that, what's this? So you're basically converting this number right here into its hex code. And so 10 would be best. Instead of me writing it out, you guys can look at this. So basically, to do your hex code, you take your You take your decimal code, you write out your 2 to the 0, 2 to the 1, 2 to the 2, all the way to 2 to the 7. That's 1, 2, 4, 8, 16, 32, 64, 128. So what equals 20? Remember, you kind of break this into 2 with 4, 1, 2, 3, 4, 1, 2, 3, 4. Well, we've got 16, 4, and 1 is 21. So then what you do is you reset this. You go 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. This is equal to 1, 2, 4, 8. Well, there was 116 in here, so you put that in there, and it's now 1. The value of 1 is 1. We had a 4 and a 1 here, so we bring this over 0, 1, 2, 3. 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. This value is 1, 2, 4, 8. So we had a 1 and a 1 here. I brought those down, so that's a 4 and a 1 is a 5. So our first value is a 1 and a 5, comma. And then you can follow through this for 60. How I did this. And again, you can do this one on your own too. Either way, it ends up coming 15, 3C, 2E. So if you don't remember how to do that, go back and study this, because again, I'm going to throw these in all of our quizzes, throughout the semester. So hopefully you guys don't forget all this stuff. You might be tested on this for your next test. So it's just a good thing to keep fresh in your mind. So anyway, this video's done.